If you've ever tried to break rocks, you'll notice that many times rocks just break in jagged and uneven chunks. Other times they may break in unique ways, according to the structure of the rock or mineral. This is usually referred to as fracture. Occasionally, rocks or minerals will break in smooth, even splits. This is known as cleavage. When a mineral is cleaved, we can see smooth, flat sides, known as facets. Let's take a look at some of the distinct types of fracture and cleavage. One unique type of mineral fracture can be easily seen in this sample of asbestos. In this silky lustered sample, we can see that the mineral breaks in these small soft fibers. These fibers were quite useful because of their insulative properties, as well as being fireproof. They could be woven into a fire-resistant material. This was used quite a bit until it was discovered that inhaling the mineral fibers could lead to cancer and other lung disorders, so it's no longer used today. Type of mineral fracture may be seen in this piece of satin spar. When broken, we can see many resulting splinters, so we'll refer to this mineral as having a splintery fracture. Some smooth and glassy minerals and rocks may have another distinct type of fracture. We can see when this is broken, it has the appearance of freshly broken glass. You may notice small rings or ripples in the surface. These rings or ripples are known as conchoidal fracture. This smaller sample here of the volcanic rock obsidian has very distinct conchoidal fracture, and we can see the rings or ripples in these freshly broken surfaces. On to cleavage. Cleavage occurs when minerals split along smooth, flat planes. Possibly none of the minerals are as unique or split as nicely as the mica family minerals. Remember, mica is a family and there are many different types of mica minerals, but we can see here in this sample that it will split and split again and split again. These layers are very thin and flat. In fact, mica can be peeled over and over until one ends up with samples that are just a few atoms or molecules thick. This is a great example of what we call basal cleavage. Basal cleavage is when a mineral splits along one. This mineral also exhibits another unique property. We can see that it is elastic. Elastic means that it's flexible to the point of bending, but when released, it will bounce back to its original form. Similar to basal cleavage, this sample of selenite is a good example of a mineral with platy cleavage. Platy is very similar to basal cleavage in that it splits along one plane. However, it's not as thin as the mica family minerals, and it resembles a stack of plates, so it's simply referred to as being platy. Platy is similar to basal, just a little thicker. Many of the feldspar family minerals show blocky or prismatic cleavage. When broken, we can see smooth facets or flat sides in two planes. These intersect frequently close to 90-degree angles, but you'll notice the ends are very jagged and uneven. So if we see two that are at 90-degree angles, we can refer to this as blocky or prismatic cleavage. If a rock or mineral breaks with 3 planes at 90-degree angles, we'll refer to this as having cubic cleavage. You'll notice that there are 3 planes resulting in 6 sides, and these intersect at 90 degrees. So this is a good example of a cubic mineral. Faces are all squares or rectangles. Similar to cubic, certain minerals that break on 3 planes that are not at 90-degree angles are referred to as rhombohedral. The resulting 3-dimensional solid is called a rhombohedron. If we look at the faces, we can see that the face is either a rhombus or parallelograms. Again, notice that this solid has 3 planes and 6 sides, but they do not intersect at right angles or 90 degrees. Other minerals cleave along 4 planes. This results in a 3-dimensional solid with 8 sides, known as an octahedron. So these minerals have what is known as octahedral cleavage. A distinguishing fact of these minerals, you'll notice that the faces are all equilateral triangles. The resulting 3-dimensional solid is that of a double pyramid. There are no minerals that have 5 cleavage planes. There are a few minerals with 6 cleavage planes.